Hi, welcome to this video on finding composite area. So we're just going to focus on composite area with these figures here, and you can see that they're more than just rectangular composite figures. They're composed of different kinds, and so identifying what shape you're seeing is really the key here. So if I look at example 1, I can see a rectangle and then a triangle, and so if I just kind of break it up and find the area of the rectangle and the area of the triangle, just being careful to realize that this triangle here is kind of laying on its side, so I would want to rewrite it and this base would correspond to this side here is 6, and the height is 7. And then knowing that, finding the area of this rectangle and the area of the triangle, and then just adding them together would give me my composite area. And when I look at example 2, I see, what shapes do I see? Well, I see a square here in the center, and they're telling me that the square's dimensions is 2 by 2. And then I see 4 semicircles. Well, 4 semicircles is really the same thing as having 2 circles. So I have a circle that has a diameter of 2, which means it has a radius, it's 1, so the radius is 1. Erase this part here. Okay. And I can find the area of a circle that has a radius of 1. That's one circle, but then I have times 2, so I'm going to just like double that area. So once I find the area of the square, which is easy to do, and so the area of the square plus 2 times the area of those circles, add them together, and that's going to give me my composite area. So those are kind of and then example number 4 is just like we were doing before. It's a very simple problem where you're just essentially finding the area of rectangular pieces. So a square up here that's 18 by 18, and a rectangle down here that's 18 by 30. And so just finding those two areas and adding them together, the area of the square and the area of the rectangle. Wow, that's fancy. This is my way of documenting. So A for area, and then I put a little square here in the corner to say I'm finding the area of the square, and then A for area, and I'm finding the area of the rectangle. And that's my documentation of that. So being able to do that, the tough one though is example 3. So let's look at that one. So in example 3, what figures do I see? Well, I see this right triangle here. And I see this right triangle over here. And then I see what appears to be a square, but it's not really, because this piece has been cut out. So let me start with these triangles here, these 2 right triangles. If I take those 2 right triangles, okay, and I have the area of the right triangle and the area of the other right triangle, I keep drawing, okay? Now if I just put them together, really, if I took this right triangle over here, and if I cut it off and I picked it up and I put it here, then wouldn't that just make a square? So don't I really have, if I put them together, don't I really just have one square that has dimensions, and its dimensions are, so to find the area of a square, I would do length times width, or base times height, either one, and I would multiply 7.5 times 7.5. So that's going to be that blue area here. And then if I look at this part of the figure, I can either, 1, break this up into 2 rectangles, or I can say, well, here's another square here, this little square, that has a piece cut out of it. So I have this red square that is 10.5 times 10.5. So I can add that together, but then I'm just going to subtract away this little tiny piece right here. What's the dimensions of this little tiny piece? Well, if this is 7.5, that means this must be 3. So it must be 3 by 3. So I'm going to subtract away this little tiny square that is 3 by 3. So when I do that, So that would mean it would be 56.25 for the blue triangles, and then 100.25 if that was a whole square there, minus 9, take out that little tiny piece, and then that would give us 157.5 square inches. So that is the area of example 3. Okay, thanks.